All right, so recovery of refrigerant out of an AC system. We're going to start moving forward on that. Basically, getting a complete recovery, there's a few different things that little tips and tricks, things that you can do that'll kind of speed up the process. Um, but the big thing is making sure you get all the refrigerant out because you want to get all the contamination physically possible out of that system as you can. So you want the best possible case scenario. Now, the older systems, anything that runs an accumulator, which is basically the same thing as a receiver dryer that we talked about earlier, it's bigger and it's on the low pressure side. Accumulators, you have a few more steps that you want to do because um, they'll really start to kind of collect a bunch of stuff inside of them. And then, just making sure the system's hot before you evacuate. That makes a big difference as well. So let's look at some of these tips and tricks real quick. Uh, so factors that affect refrigerant recovery. The amount of refrigerant you can recover from a system depends on how much is in the system, of course, but also depends on ambient temperature, the technique that you use to remove the refrigerant, and the performance of the recovery machine itself. Over years of operation, those recovery machines, they lose some of their suction capabilities, and so they may not be able to perform as well as brand new machine. Well, you'll also notice that previous slide was highlighted. A lot of times they uh, ask a question about factors that may affect refrigerant recovery. Just remember how much that's in the system. Ambient temperature will affect how much you can pull out. The technique you use determines how much you can pull out, as well as the performance of the recovery machine itself. All right, so systems equipped with accumulators may require additional time and precautions. This is kind of the getting into the process that you use, whether or not you're able to get all the refrigerant out of there. And this is that bigger accumulator on the low pressure side as well. So basically, what happens here is to remove as much refrigerant as possible during the recovery process. Systems equipped with orifice tubes and accumulators. So this is not the H-block expansion valve, this is the orifice tube accumulator, require more time than systems equipped with the expansion and receiver dryers. This is mainly because of the design differences between the accumulator and the receiver dryer. Being larger than the receiver dryers, accumulators, located on the low pressure side of the system, hold more refrigerant and oil than the receiver dryers do. When the refrigerant is removed from the system, the lowering of the pressure results in some of the system components becoming cooler. This component cooling effect makes complete refrigerant removal in a short period of time more difficult. So, during the recovery process, as the system is drawn into a vacuum and pressure in the accumulator is lowered, the accumulator becomes very cold, with the external frost sometimes visible on the accumulator. So it's starting to freeze up, making it hard to pull it out. This makes it even more difficult to extract the remaining refrigerant from it if the liquid refrigerant has not been removed and the refrigerant lines are opened. As the accumulator warms, a sudden release of refrigerant and oil can occur. So this is a little bit older systems. This isn't the brand new things. A lot of the brand new ones, they run the H block with the um, uh, receiver dryer. This is the older systems that run a orifice tube with a accumulator. Those accumulators, they'll freeze up when you're drawing a vacuum on them. So what you'll want to do is get like a little heat gun, like a hair dryer would even work. A heat gun, don't use open flame by any means, but a heat gun works pretty good. Uh, short, point it at the accumulator, heat her up, just basically make sure it doesn't freeze over is all you're doing there. Um, if you don't have a heat gun or you don't have access, so it's in a really bad position, the accumulator's in a bad position, what you can do is do an engine preheat. Um, so the engine preheat, uh, once again, it's in your manual, gives you a full step-by-step procedure, but we'll just kind of touch on some of the uh, main aspects of doing an engine preheat. So first off and foremost, you don't want the AC working. If the AC working is trying to work, so the compressor is operating, then potentially it's putting cold freon through the system. You don't want that. You just want the freon sitting still while the engine itself is getting hot, so it's heating up the whole system. You want your blower on high, that way it's still circulating, but not actually cooling. You'll want to run the engine about 15 minutes with the hood open. That way the air can enter the cowl and vents. Uh, Fairly simple. Just make sure the AC is not on. The blower is on high, pulling the air in from outside, and the engine is running and getting hot. All right. During recovery, so this is after you've done all the pre-checks, everything, you've started to recover, you've pulled it out. After the system is drawn into a vacuum, so you're recovering all of the uh, refrigerant out of the system. Now it's going to start to pull a vacuum on the system to make sure it gets every last little bit of refrigerant out. Um, Either the machine is going to automatically pause or you need to pause the machine and wait for 5 minutes and watch that gauge. If that gauge starts to rise from a vacuum, so a negative pressure, then that means one of two things. Either there's still refrigerant in the system and you need to recover longer, or the system has a leak. Either way, not a good situation. If it's just a refrigerant in the system, you continue the recovery, let it run another 10-15 minutes, check it again. Um, you're normally going to do it 2-3 times before you determine, okay, there has to be a leak. I'm going to go find it. Uh, let's see here. Uh, do, 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 do. You need to continue this until the vacuum can remain stable for at least 2 minutes. It needs to be able to hold that negative pressure. Uh, that goes for when before you charge it too. So you've already recovered it, you've already fixed the system, you're getting ready to recharge. You do the exact same thing. You're going to recover just the atmospheric air out of the lines, and then you're going to hold it in a vacuum for an absolute minimum of 2 minutes. I usually let it run for 5 minutes, and it should stay at negative pressure. It shouldn't rise, but maybe 1 psi or two. Um, and that kind of tells you, do I have any leaks and is there anything in the system? Uh, so most newer recovery machines automatically perform the vacuum. 5 minute pause, check for the pressure rise, recover if necessary, check for 2 minutes of stable vacuum procedure. That's the brand new, nice recovery units. They don't all do it. Just watch your gauges. You know you're gonna set it to recover for 15 minutes minimum, usually 30 minutes. It's gonna recover. It's gonna pull it into a vacuum. Just go look at your gauge, and then go look at your gauge again 5 minutes later. If it hasn't gone up, but maybe 1 or 2 psi, you're good to go. If it has, just put it into recover for a little bit longer and move on. All right, so after recovery is complete, check the machine's oil reservoir. So first of all, and this their little presentation thing didn't say it, you should always check your oil reservoir prior to doing a recover, just so you know exactly what level the oil's at. A lot of the times, guys in the shop, you're supposed to always empty the return or old oil, lube oil, bag oil bottle out of the machine. A lot of guys don't. Now you're not going to build a whole lot of oil in there, but just in case, you need to make sure there's no oil in the return side or suction side of your machine. Um, so check it first, run the recover, then you need to check it again and see where the oil level's at. Because any oil that you pull out of this system, you need to put new fresh oil back into the system. It's not very common that you're going to pull a lot of oil out. It's In fact, usually you don't pull any oil out of the system. However, it is possible, and you always need to put that exactly that much oil back into the system, because if you don't have the right amount of oil, you could burn up your compressor, or a billion other things can happen. So you always want to put fresh oil back in. Now, the oil that did come out of the system, that's bad oil, and it has to be disposed of properly, because technically that oil has been contaminated by ozone depleting um, substances, right? As well as it's just oil, so it's got to be disposed of correctly. If you don't know what that is, MSDS, whatever your shop typically does, follow whatever your manager says. All right, so this is a picture of the oil reservoir right here. It should be empty before you start. There'll be another oil reservoir right beside it with good, fresh, clean oil. Um, this one, it'll fill up, let's say it fills up to, I don't know, what is that, 10 milliliters. Then you're going to put 10 milliliters of the good, fresh oil back into the system. And there's a little button on the machine that says inject. You just inject it in. If you don't have that, then it's a needle and syringe, and we'll get into that later. But hopefully, generally, you're not going to recover any oil, so it's not something you got to worry a lot about, but you do need to pay attention just in case um, it does happen. If you do pull a whole bunch of oil out, typically what that's a sign of is the system was overcharged with oil to begin with. Compressors, some compressors come with oil in them, some don't come with oil in them, some come with the wrong oil in them, shipping oil. You need to know what type of compressor you're putting in. Um, Generally, what you're going to do, every compressor, just to save yourself any headache of ever messing up, generally what you're going to do is you're going to get a compressor and you're going to dump all the oil out of it. As soon as you get it brand new off the shelf, you're going to open up the fill plug, turn it on inside, and you're going to drain all the oil out of it. You're then going to fill it back up with the right amount and the right type of oil. Usually it's going to be R134A, so it's going to be PAG oil rated for R134A. You're going to fill it up to exactly how much oil that system takes. Now that's going to be stamped. It's going to be all over your manuals. It's going to be labeled on the truck. It's going to maybe be labeled on the compressor itself. But some of the compressors, they have little dipsticks. Some of them don't have dipsticks. Somebody in the shop may have built their own dipstick. Ask around, read your manuals, get the right amount of oil put back in that compressor, and then install the brand new compressor on. Like I said, you just have no idea. Every company's different. Some of them have the wrong oil. You don't want to run the wrong oil in there. They just put in a shipping oil, or maybe they put in the right PAG oil, but it gets contaminated with water. I mean, there's so many things. So you just dump them all out. Some don't come with any oil. That's worst case scenario. You don't want to put a compressor on that doesn't have any oil in it. Otherwise, you're going to burn it up. So always check that. Make dang sure you're filling it up properly. Um, and here's PAG oil for 134A. These R12 systems, they use mineral oil, a little bit different, but every type of refrigerant has its own sort of oil. So always make sure you're putting the right oil in the right refrigerant. R134A and R1234YF are belt-driven compressor systems. Both use PAG oil. R744 and 152 and new blend refrigerants may each require different lubricants. Make sure you got the right ones. Too much air in the refrigerant can cause operating pressures to be too high. This can cause poor AC performance with outlet temperatures higher than they should be. Some of the systems, they'll have little sight glasses on them where you can actually see the bubbles flowing through. You're going to see some no matter what, but you don't. When we get into diagnostics, we'll actually talk about exactly what you're supposed to see. But that's as far as we're going for now because we are out of time, so I'll catch you on the next video.